Hello, everyone, and welcome to Concordia University's Fourth Space. Thank you for joining us for today's event, INDU Talks podcast, A Taste of Engineering Life, Industrial Engineering for CEGEP students with Dr. Masoumeh Kazemi-Zanjani. It is now my pleasure to hand it over to the VP podcast for the Concordia chapter of the Institute of Industrial and Systems Engineering, Jose Garcete. Jose, over to you.
Thank you for the introduction, Jax. Thank you to the Fourth Space for having us here again. Hello, everyone, and welcome to INDU Talks, your #1 podcast on all things industrial engineering and much more. My name is Jose Garcete, and I'll be your host for today's episode.
So sorry, just one moment, Jose. It looks like your microphone is having an issue. We're just going to come fix it.
Okay. Thank you for that. So as I was saying, thank you to the Fourth Space for having us here again. And hello, everyone, and welcome to INDU Talks, your #1 podcast on all things industrial engineering and much more. My name is Jose Garcete, and I'll be your host for today's episode. In today's episode, we have a very special guest. She's one of the most esteemed and respected professors within our faculty, and she's one of the associate chairs of the faculty. Her name is Dr. Masoumeh Kazemi, and I'm very happy to have her here today. Thank you for joining us, Dr. Kazemi.
Thank you very much, Jose, for inviting me, and thanks for the space for having me here. It's a pleasure to have a chat with you today.
The pleasure is all mine. Thank you so much.
Thank you.
So starting off with our podcast and our interview today, I wanted to ask you, Dr. Kazemi, what inspired you to pursue a career in industrial engineering? And what aspects of the field first captured your interest?
Well, when I chose industrial engineering for undergrad, I almost knew nothing about the major. So at high school, I always loved math and computer programming. So when it came the time for me to choose like a field for my university, like undergrad degree, I really didn't know what I wanted to do. So I was thinking about going to computer science, software engineering, or maybe more traditional like mechanical engineering. So then the thing is, as I said, I really loved math, but I wasn't much into physics. So then I thought, okay, maybe mechanical engineering, not such a good idea. Then I consulted with some teachers at high school, like with my parents, and because I also liked business administration. So at the end, talking to people, I decided maybe industrial engineering is the one for me. Then I decided to get into the field. And the good thing is, as soon as I started, like after the first year, I finished it. General courses. I started taking courses on time and motion study, and then something similar to lean. And later on, I took operations research 1, and suddenly everything started to make sense because by nature I'm an organized person. So, and I know I was always passionate about planning, scheduling things. So when I took OR1, and I suddenly, wow, I understood the meaning of optimization, hearing about efficiency, and that's what really motivated me. I got fascinated about this notion of efficiency and optimization.
For me, it was similar as well. I started in industrial because I really liked math, and I wanted to look for a major where you could apply math and use it in a more general sense in different fields. So I can definitely resonate with that, and I agree that it's very, very similar to business administration as well.
Yeah.
Have you had any experiences where you personally, like in first hand, you see it, industrial engineering used in a business management type of way? Have you had that role?
Well, after I graduated, from my bachelor's program, I started working as a consultant, like management consultant.
Oh, wow.
And because one of my professors had a consulting company, and I did my capstone under his supervision, and then he invited me to join his company because he thought I might be useful and could contribute to the company. So I literally got into consulting, and that was one of my favorite professions I was looking for. So I worked in the field, and I had the experience of working with managers, and that was very eye-opening.
Was consulting Did you do it back in Iran?
Yes, that's
After
my
your-
home country, yes.
Okay. And what did you have to do as a consultant?
Well,
What responsibilities
typically,
did that entail?
the companies come with a problem.
Mm.
Okay, so one of them I remember the very first project was in dairy production. So it's the biggest dairy production companies in Iran, and then they come to this consulting company with a problem, like they had a lot of inefficiency problems in their manufacturing line. So then they literally come with an open-ended problem. Okay, so they come, the manager explains what is not going well in the company. It's like they go to a doctor. So and they say, you industrial engineers, you claim you enhance productivity, efficiency, eliminate waste. How can you help us? And then that's how we started the project. Like later on, because Iran is a big producer of oil and gas, you might know. So we got projects from oil and gas sectors as well. I have some experience in that department too.
Okay, interesting.
Yeah.
Personally myself, I want to go into consulting, so this is good information to hear.
Yeah, but later on, maybe I'll also mention to some challenges I faced when in consulting, I think.
Like later on the interview?
Yeah,
Oh,
if
okay,
you are curious to know.
Yeah, I am very curious, about some of the challenges. Could you talk about those maybe?
Well, the very first challenge is to really convince the managers that a problem exists, because, as a manager,
By managers, you mean your superiors?
No, the company
Oh, the
who
company,
approached
okay.
you, so let's say that dairy production company, like the production manager who approached us, in their mind, they were doing everything properly, and generally speaking, the directors and managers in an environment, they don't like to be criticized, right? So it's not really a pleasant experience to be criticized. It's human, like it's the nature of human. So first thing first, like you go for a visit and you look at the things from an industrial engineering lens, right? So you right away find some issues, then you start talking to, let's say, to the sponsor of the process, etc. It's really challenging to convince them that what they're doing is not what they're supposed to do, that's why the problems arise and they're struggling. And the second challenging thing is to sell your ideas to them, to convince them the solutions that you're proposing is really worth investing money and time,
The appropriate solution,
That's, I found quite challenging. And then I started thinking how creative I need to be. And the first thing I learned, I should avoid jargons when I talk to managers, like, you cannot talk about technical terms with them. I cannot talk about operations research models with them. You need to find a way to explain the concept in their language, whatever language of the work environment they speak, And that needs a lot of experience. So at the beginning, I found it very challenging.
What do you give as advice for people that have trouble communicating their ideas in a less technical term, in a more common ground, more easy way to understand type of way?
Well, you should know what you are doing.
Okay.
So you should really know what, like example, when I develop an optimization model for a company, I should really understand what that model is doing, and then I have to translate that math model into very fluent English, and I have to speak about the tangible outcomes of what I'm proposing, and that would be like the financial outcomes, the bottom line, how it's going to impact the profitability of the company, how it's going to reduce the cost, how it's going to make the employees' experience better, how it makes them feel better, to help them want to contribute to the productivity of the company. Yeah. So the first thing is you really need to know your material. You understand it well, and then from there you start to communicate and talk about the benefits. So.
Yeah, I can't imagine what it's like to explain a mathematical model.
Yeah.
full of different variables and mathematical equations that a manager maybe couldn't understand.
Or a simulation model.
Right, or
like I have like a replica of your factory on the computer. What does that mean? Like what it is doing, you know? So yeah, so that was one of the most challenging parts.
Okay.
Yeah, and if I may say, second thing I found a bit challenging in studying industrial engineering is that you learn a lot of topics, right? If you look at the curriculum, there are many, many topics we learn, but we don't learn them deep enough. Because, you know, you take a course, you start learning something, but we never get deep into like all the math or what is behind like simulation, what is behind mathematical programming. Even programming, we do programming, but we are not like software engineering students who really get deep into. And that's why when you want to apply these things in practice, sometimes you feel like you're lacking some knowledge.
I think I found that same challenge when I was taking OR2 with the Python programming language. I never learned how to use Python before, so I had to teach myself the basics of Python with the lab manual that you provided, which is very challenging, but it was in the end very worth it, because now I can look at a model and make an attempt at putting it into Python and optimizing it. So I definitely understand that. What would you say is a way that students can improve or prepare for themselves for that challenge, as far as the course not providing the full in-depth information or learning that the student might need to make it easy for themselves?
So the first thing is to be open for learning more and more and more. You know,
never stop learning. I agree
exactly.
With that, yes.
So that's what I learned it in practice, you know. So I quickly understood, how much I don't know. And this getting into the habit of self-learning, do research, is what we call lifelong learning. And if you have noticed, in most of our industrial core courses, we have projects. We give projects to the students.
Yes.
One of the objectives of these projects is this teaching them the self-learning, lifelong learning. How when you see a problem, you feel a knowledge gap in you, how to do research, go teach yourself. So that's the key. And actually that is what motivated me to go to grad school, because I thought what I learned in undergrad wasn't enough. So I wanted to learn more about operations research. As I said, I got really fascinated with this topic because I could see you could summarize a complex decision-making problem into an abstract math model. And then you can solve it and you find some optimal solutions or close to optimal solutions. So I wanted to learn more.
Okay, interesting.
So there's no magic spell for it. It's just to be open for learning and push beyond the boundaries of your comfort zone. If you need, go do a master's program.
I completely agree with that, and it's a good habit too to make out of life, because in general, if you make the habit to keep an open mind and learn from everything, it's better. You don't have a closed mind, so it's very good. I agree with you.
I mean, it's not easy, it's challenging, but there's no other way around. There's no way we can teach everything to you guys at school. It's simply impossible, because real world problems are new problems. We haven't seen them before.
Exactly, yes. So moving on to the next question, Dr. Kazemi, looking back on your career, what are some of the most valuable lessons or skills that you've gained from working in industrial engineering? And are there any specific challenges that you faced that helped you grow as a professional?
Well,
I think that the challenges
the
question
challenges
you already
I
answered,
somehow answered, but
as
what
far as
skills I learned? Well, I can say any work environment, any facility I go into, I look at the processes and operations from an industrial engineering lens. It's the way I see things. You know, I go to a clinic, I go to a post office.
What do you mean by industrial engineering lens?
Like I see everything as a system, right?
Uh-huh.
I see that when I go to a clinic, to a post office, even to a grocery store, I see that there are activities that are done in sequence. I see clients are coming, I see the whole process, I see the outcome. I look at it from a process perspective, like, you know, and then I start analyzing the process. That I learned it through this program, industrial engineering program, to start looking closely into the processes, how things are done, and then start evaluating. Are they being run as they're supposed to? Are there some inefficiencies? That's a skill that anywhere I go, I start catching inefficiencies. So, because this efficiency for me is a very important keyword everywhere. So that is one of the skills that I acquired. Let's say anywhere I go, any job environment, any facility, I'll start to see if things are running in the most straightforward and smooth way. What are the problems? I start seeing the problems. So that's one skill. The other one is that it helped me to really apply this notion of efficiency and productivity in my personal and professional life. So even in my personal life, I've learned a lot of key aspects from this field that I can apply in my life. Like I have a busy life, you know, I have a family, I have a job, very demanding job, how to prioritize things, how to plan things, how to schedule. So I think I benefited a lot in my personal life and in my career too. So I try to, like, you know, achieve all of my goals, set priorities to fulfill all of the tasks I'm supposed to do. So, yeah.
Recently, I'm taking the lean manufacturing course right now.
Yeah.
And we were just taught the 5S methodology, which is sort, set in order, shine, standardize, and sustain, if I remember correctly. Yes. And it's something that since I learned it, I've seen it in my life, that I've been applying it the whole time, and it actually does make a difference. Like if you keep your things organized, in order, clean, and you make it a habit, everything else just feels so much more easy, and you're more motivated to not be lazy and to really put in the effort to do things well. So I agree with you completely, and that's why I love our major so much, industrial engineering, because it's something that you can apply to anything in life, in any field.
Exactly, and that was the last thing I wanted to mention, that it opens a lot of possibilities. You see that, wow, you can apply what you have learned everywhere. Like there's no limit. Like if you are passionate about manufacturing, you can go do a job in manufacturing. If you don't like it, you can go to service sector. We had students graduated from our program, they went to like a high-end fashion industry. They were applying inventory management in those settings, you know. You could go to logistics, you could go to retail, healthcare. So that's another thing that I learned, that the possibilities were and occasions I can apply my knowledge and skills.
Yes.
Yeah.
This is great things to hear, yes. I agree completely with you. So moving on to the next question. So before we dive into the more CEGEP student-related questions, I wanted to ask you, just give me a second, sorry.
Take your time.
So, how would you explain industrial engineering to a CEGEP student who has never heard of it before?
Well, I would say it is engineering of systems. So us as engineers, we don't build things. We're not like mechanical engineers that they build machineries, equipments. We're not like electrical engineers who build like electrical devices, optical devices, telecommunication devices. We are not software engineers who develop codes. We analyze the systems and we optimize the systems. What is a system? A system is a combination of resources like people, material, equipment, and a sequence of processes, which is different steps to transform one input to an output. When you look at this system, you need to decide how much resources you should allocate to different activities to get the maximum output. And you have to reduce the cost you spend to deliver the output. So our goal as system engineers is to maximize efficiency, minimizing the waste and non-value adding activities in the processes. So our objective is to design and streamline and enhance complex systems.
Kind of like the value stream map from lean manufacturing?
That is one of the tools, but in general, if you look at any process from the beginning till the end, there are different ways to run the activities. So we want to do them in an optimized way. We also want to design work environments such that it is safe for the human, and it's easy to use, and it uses the least amount of resources. That's what we call efficiency. You want to deliver high quality outcomes. So that's why we learn about quality control and quality engineering, to minimize the defects and non-conformities in our outcomes, but by using the minimum amount of resources. So to do that, we need to optimize activities. And we learn tools and techniques that helps us how to design the work environment, how to design the processes. So I call it engineering of systems.
And by engineering of systems, these are systems that can be seen anywhere, in any type of field. So this is a separate question, kind of off topic, but why do you think that industrial engineering has a smaller presence among CEGEP student graduates compared to international students at a university like Concordia, for example?
Well, this question I think has two parts. One part is in general why industrial engineering is less known as compared to other engineering disciplines. I guess because it's kind of youngest engineering field among the others, like mechanical engineering, electrical engineering, civil engineering. They existed for a very long period of time. I don't think industrial engineering is that old. It just really picked up, I think, in end of 1980s, 1990s, and then it picked up really in the United States. Especially, it's very popular in the United States. In Canada, I can see it's less popular, yes. And there are less schools that even offer this undergrad program, right?
I think here in Montreal, as far as English-speaking schools, Concordia is the only one that offers it,
exactly,
correct?
Exactly. Yes. We are the only English-speaking school offering this program, and also in CEGEPs, I think students more get exposed into math and physics. And as I said, we don't deal with physics at all. Like, we don't use physics in our major. We use computer programming, use applied mathematics, probability statistics, a little bit of business administration, some social sciences. So as you know, industrial engineering is kind of multidisciplinary. I'm not sure how CEGEP students could get exposed to this field, because they're mostly more traditional fields in engineering, like physics, you know, chemistry, physics, you know, and we use less of those topics. So that's one reason. Why Concordia especially is not well known, because as you mentioned, we are Anglophone, and most of the CEGEPs in Montreal are Francophone, so maybe we have less presence in them. So I think this is it. So maybe some CEGEP students, they prefer to join Francophone universities. It's like easier for them. But yeah, I agree that a lot of those CEGEP students, they have no idea what industrial engineering. Like, I was feeling that back my time, I really knew very little about. I knew a lot about mechanical engineering, but I didn't know about industrial engineering.
I've spoken to a lot of the CEGEP students that came here to Concordia, and they tell me that throughout their CEGEP studies, they didn't really see any industrial engineering programs. As compared to mechanical engineering, that I know they have technical programs for that in CEGEP. So I completely agree with you, and I was caught by the point that you made. Industrial engineering grew in popularity during the 90s and the 80s. Is there a specific reason to that that you might know of?
Well, actually, after let's say, countries became industrialized and the mass production picked up, then suddenly the business owners started observing inefficiencies, quality issues, you know, and it all happened when the mass production happened, you know,
right.
Because if you produce in a small scale, even if you're not very efficient, because you're not on rush, your orders are not on rush, you could delay it a little bit. If you made mistakes, you could fix it, you know, it doesn't cost you that much. But imagine if you have huge amounts of orders to deliver in time, and if you don't deliver, you have to pay penalty, you will lose customer loyalty, etc. Then you start thinking, are we doing things in the most efficient way? Are there other things we could think about? And also one of other motivations of industrial engineering being very popular, especially operations research, was in military operations. I don't know if you have heard about it, this whole OR field.
In World War II, it began with...
Created based on these needs of the military to where to deploy the forces, where to locate the resources, facilities, and it all started from there, you know. So I would say, yes, civil engineering existed because there was a need for building bridges, you know, roads. Mechanical engineering was required for like building machineries, etc. But as soon as the mass production happened, then people needed a field for engineering the systems, looking at the whole system and see that how the whole system could be optimized. Because the mechanical engineer will optimize the performance of a product, right? The focus is just on the product. It's not on the process where you build this product.
Or you mass produce it.
You mass produce it.
You organize the production point behind it.
You have to be consistent in terms of quality. Every unit you produce should have the same quality, right? You should use the minimum amount of resources because then the competition comes. You have other competitors, like globalization, so you need to reduce your costs, right? Even if you produce the best products in the world, but it's too expensive, nobody's gonna buy it, right?
Talking about quality, I know that you teach the Introduction to Six Sigma elective here at Concordia.
Yes.
How did you gain so much insight into Lean Six Sigma from an industrial engineering background? I'm kind of curious to learn about your experience with that. How did you go into Six Sigma coming from industrial engineering?
Sure. Well, you know, in industrial engineering, we take a course on quality engineering, right?
Quality control, yes.
Yeah, quality control and reliability.
And we learned the DMAIC methodology?
DMAIC, no, we don't. I mean, we didn't have it. When I was doing my undergrad, I wasn't familiar with the DMAIC. We call it DMAIC in Six Sigma. But I knew quality and I knew Lean. So then I started reading about Six Sigma and I realized, okay, Six Sigma is all about eliminating defects and quality issues and non-conformities from the processes. It's very process-oriented. So us industrial engineers, we are familiar with analyzing processes, right? So it's process-oriented and I want to eliminate the defects. So it's quality. I can use my knowledge of quality. And it's also about reducing the cycle time of the processes. So it's Lean. Then when I looked at the DMAIC phases in Six Sigma, and I saw there's a lot of probability statistics involved, and we know about probability statistics. So Six Sigma is not a new thing. It's like putting many things that the industrial engineers know as a framework, as phases. You implement them in phases to achieve the goal of almost zero defect processes.
Okay.
Yeah.
Is that the, I remember when I took quality control in Six Sigma that the goal is to keep quality within 99.7% of the entire production?
Yes.
Am I correct in that?
Well, that is traditional quality control.
Okay.
That
What's the
99
difference?
I tell you, 99.72% of items should be conforming to customer specifications.
Okay.
In Six Sigma, you can only afford 3.4 errors per million opportunities.
Okay, wow.
So it means that the variations in your process should be very, very small.
Yes.
You should always produce close to your target.
And it's easier to achieve that in a pull system as in lean manufacturing rather compared to a push production system, or there's no...
You're talking about two different notions. Of course, if you don't produce according to a pull system, it means you will have more overproduction. You will have more work in process. More work in process means more quality defects, because you are storing items in like really half-produced items in the supermarket and keeping them, and over time they might get damaged, you know. So in general, not following lean means having more opportunities for defects and quality issues. And in that sense, they are related. But really, Six Sigma is really about looking into your processes and eliminate every opportunity that can create non-conformity. So you really have to redesign your whole process to, I mean, I don't know if you've heard about Pocoyoke approach. It's called error proofing. It's like really thinking out of the box, how to eliminate any chance of non-conformity. If it's by using sensors, installing sensors on the machineries, cameras to just see the parts, as long as if they're misaligned, stop the line, align the part. As I said, like other types of cameras, etc., using AI to really not letting defects happen. And that's how, at the end of the day, when you produce 1,000 units, all of those 1,000 units are going to fit into your tolerance limits.
They'll be kept in check.
So you mean you have zero defects. That's the whole philosophy of Six Sigma, which is not easy. It means you have to use a lot of tools to achieve it. It's not just one single tool. It's like you have a toolbox, and you have to be creative depending on the context, decide which tool. And that brings me to my first point. You see a problem. It's so difficult to see what kind of tool I should use to achieve my goal of error-free processes.
It really requires you to analyze the issue and the system behind it.
Map the process, analyze the process, collect the data. Six Sigma is a lot about collecting accurate data and analyzing the data.
And using the appropriate tool.
Exactly, appropriate statistical tools to get really concrete conclusions about the root causes. And then again, thinking out of the box how to fix the problems. You can identify the root causes, but then the next step is how you eliminate those problems. And then at the end, how to make things sustainable over time. Because the Six Sigma is a project you implement, it's finished. You need to make sure that the changes are sustainable. Things won't go back to where they used to be after the team leaves the company and finishes the project. So it's really a 5-phase of define, measure, analyze, improve, and control.
Okay, very interesting. Thank you, Doctor. So moving on to the last question. This is more a message for the CEGEP students that might be watching and looking at the different career options that they're offered within their CEGEP. What message would you give to them, to the CEGEP students who are exploring potential careers, about the opportunities and flexibility that industrial engineering offers?
Well, what I could say is that, as I mentioned at the beginning of my interview, I think the areas that can apply industrial engineering is numerous. They could, if they're more passionate about production, manufacturing, they can pursue a career as like a production engineer. They can really get more take more courses related to production planning, control, quality, inventory control, and also manufacturing, and go into that field. They can go into logistics. Like think like Montreal is like a logistics hub. Like we have a port here, there's maritime transportation going on. Can you imagine the whole operations in the ports is the job of industrial engineers. Where to locate the containers, how to design the container yards, how to or let's say coordinate the cranes, the trucks, you know, the scheduling of the trucks and the freight transportations in the city. So it's a big field for industrial engineers. We have a public transit system. Industrial engineers could go work in public transit, air transit. Like we have our graduates go to airline companies, they work on revenue management models. There is a lot of opportunities about data analytics and data science nowadays with the advancements of AI. And in our programs, we are developing new courses on AI in industrial engineering. Yeah, that's a very exciting initiatives we took. This year, like we have a new course actually about
being offered right now.
Yes,
at
yes,
Concordia.
the same semester. It's called Data Analytics in Industrial Engineering. And it's about teaching industrial engineering.
Can you tell us more about that?
Yes. Yeah, it's about teaching industrial engineering students how they should go collect the data, how they cleanse the data, how they organize the data, how they capture patterns from the data. We teach you supervised learning, which means that if you have some data, learn from them and try to predict. You can use it for forecasting. I'm sure a lot of you have to know what forecasting is, but now this is about using advanced machine learning algorithms to predict the future, the demand, the prices. So that's the very exciting field that you can get into, and it has applications in supply chain. Like an industrial engineer could become a supply chain manager. It opens a lot of opportunities. You could go to healthcare. If you're very worried about the healthcare system here, you could go to industrial engineering, and upon graduation, you could go help hospitals to organize their operations and to optimize the operations, increase the quality of the service. So as I said, there are numerous opportunities for industrial engineering graduates, and that's, I think, is a good motivation, should be a good motivation for students who love math, who like to go to engineering, but they also care about the business administration side of things.
Aspects of things, yes.
So I would recommend them to go to industrial engineering because we teach some very powerful quantitative tools to them. You know, mathematical modeling, simulation, like queuing models, stochastic models. We help them really analyze complex systems and optimize them with engineering tools. So that is really the big difference between us and a business school. We really care about teaching our students some concrete quantitative tools for optimizing the systems.
I've had the pleasure of taking most of these courses that you talked about, simulation, operations research, Six Sigma, and I completely agree with you. I think it's a very fruitful major that you can apply anywhere. And I'll definitely be looking into the data analytics course for the next year, for my remaining
Yeah, I
electives.
hope you can take it. It is very interesting. It might look a bit challenging at first because, of course, you need programming. You have to code these algorithms. But I would say Python has made our lives much, much easier because there are so many libraries already available in Python. Especially there's one for machine learning. So you don't have to code the algorithms from scratch anymore. You know, it's not like 20 years ago when you had to really code everything from scratch. In Python, with the new libraries, it's very straightforward. You're open to learning. I really recommend it to all of our undergrad students. Really look for this kind of courses because that's the future. Maybe in 5 years, all of our jobs are going to be somehow related to analyzing the data, making sense out of the gigantic amount of data that has surrounded us.
I completely agree. Thank you so much, Dr. Kazemi. That's all that we have for today.
That was my pleasure. Thank you for inviting me.
It was all my pleasure as well. And thank you for everyone who are watching and tuning in for the IAC podcast, INDU Talks. Don't forget, you can catch this podcast episode on multiple platforms, including YouTube, Instagram, TikTok, and Spotify. Thank you. And stay tuned for more episodes, and I'll see you on the next one. Thank you again to the Fourth Space, and thank you, Dr. Kazemi.
My pleasure.
All right, thank you everyone for coming. Thank you, Jose, for hosting, and everyone here at Fourth Space and activating this conversation. Everyone online, those who are in the space, thank you for the questions and for participating as well. And if you'd like to revisit, this talk is already available on our YouTube channel if you want to revisit or share it with your colleagues and friends. We'll be closing up the live stream now, and please join us again on the next event at Fourth Space, and have a great Monday.
Thank you.